So just a few days ago, Google DeepMind introduced something called AlphaEvolve. It's a coding agent powered by Gemini. And while that might sound like another fancy AI name drop, this one's different. This time, we're witnessing something much more profound. An AI system that's not just helping build technology, it's helping build better AI. It's creating a tighter feedback loop, accelerating innovation faster than we've seen before. And what makes this so wild? It's already working inside Google. This isn't a demo. It's live. Right now. Let's break it down. Because this is something that could reshape how we think about code, optimization, even intelligence itself. AlphaEvolve is what we call an agentic system. That means it doesn't just take instructions. It plans, tests, learns, and improves on its own. It was designed to solve hard problems by generating smarter, faster solutions without human guidance at every step. It's already discovered new matrix multiplication algorithms, solved open math problems, and optimized everything from chip design to data center operations. But how? Well, picture this. It all starts with a human setting the goal, basically asking, what's the measure of success? Then AlphaEvolve gets to work. It pulls from a huge program database, a memory bank of code it's tried, tested, and scored. Then a prompt sampler grabs snippets and ideas from that database and turns them into a new question for the AI. From there, the language model writes a new, better version of the code. That version is tested by an evaluator pool, which scores how much faster, cheaper, or more accurate it is. If it wins, it goes back in the database and becomes the new baseline. And the cycle begins again. Over and over, AlphaEvolve keeps refining. Not just coding, but learning how to code better. Every loop is smarter than the last. But here's where things go from exciting to insane. Google is already using AlphaEvolve in production. Real systems. Live infrastructure. For example, it helped optimize job scheduling in Google's massive server farms, where memory and CPU cycles are often wasted. AlphaEvolve came up with a new heuristic, a smart trick, to distribute jobs more efficiently. The result? It recovered 0.7% of compute resources across Google's entire data center fleet. That's huge when you're operating at hyperscale. But it didn't stop there. It took on chip design too. Specifically, the TPU circuits, those chips designed for AI workloads. AlphaEvolve rewrote some Verilog code, the language used for hardware design. Engineers verified the change. And now that new, AI-optimized code is part of future TPU hardware. Result? Less power usage, fewer errors, and better performance where it matters most, in AI training. Speaking of which, it even helped train Gemini itself. You heard that right. Gemini helped create AlphaEvolve, and AlphaEvolve turned around and made Gemini faster. It optimized critical kernel-level computations, which are used in the core of model training. The result? A 23% speed up in some of the most important math operations, and a 1% reduction in total training time. And when training takes weeks or months, 1% is a big deal. Now, here's where it gets wild. Remember matrix multiplication? It's fundamental in AI. Neural networks, graphics, physics, almost everything. Back in 1969, Volcker-Strassen discovered a clever way to multiply 2 by 2 matrices using 7 multiplications instead of 8. That little trick led to massive gains in computer science. And for 56 years, nobody found a way to beat his method for multiplying 4 by 4 matrices, until AlphaEvolve. It discovered a way to do it in just 48 multiplications instead of 49. A breakthrough math problem solved, not by a mathematician, but by an AI. This wasn't just optimization. This was discovery. No human math proofs. No academic papers. Just a machine testing, evolving, and learning until it landed on something that worked. And the impact is real. AI models like Gemini, GPT, and Claude perform billions of matrix multiplications. Shaving off even a single multiplication per operation can save massive amounts of compute. That one discovery, it already contributed to that 1% boost in Gemini's training speed. Now let's pause for a second. You might be wondering, where does this lead? Is this how self-improving AI begins? According to researchers, AlphaEvolve already offers a glimpse of that future. Imagine it not only creating smarter code, but also improving its own evaluation criteria. Imagine a loop where AlphaEvolve enhances the model it came from, making each generation of AI faster, sharper, and more capable than the last. That's not science fiction. That's exactly the kind of loop Google's researchers are talking about. In fact, they've already begun discussions on how to distill AlphaEvolve's breakthroughs directly back into the base models. If they close that loop, we're talking about recursive self-improvement, the holy grail of AI development. And yeah, if your sci-fi alarm bells are ringing right now, they should be. But let's ground it for a moment. Today, the improvements are still measured in percentages. 1% faster here, 0.7% efficiency there. But if we zoom out, that's exactly how exponential growth begins. Step by step, improvement by improvement, until the system starts to improve faster than we can keep up. And then, the game changes. What makes this more alarming, or more exciting, depending on how you see it, is that AI research doesn't face the same bottlenecks as physical labor. AI research can be done entirely virtually. No factories, no materials, just data, code, and compute. Which means the moment an AI can fully automate AI research itself, you're looking at the potential for an intelligence explosion. And here's the crazy part. We're not talking decades away. It's 2025 now. In 3 years, by 2028, it's entirely plausible that we'll have AI researchers capable of making groundbreaking contributions, completely autonomously. Feedback loops will tighten. Training will accelerate. Systems will stack on top of each other, pushing innovation to speeds we've never seen before. And all of it started with a system called AlphaEvolve, quietly rewriting the rules of progress, one improvement at a time. So the next time you hear about a new AI system, ask yourself, is this just another tool? Or is it the start of something that can evolve?